This is a Fault Seal Challenge interactive app designed to provide users with a hands-on visual learning experience about the critical concept of fault sealing in sedimentary basins. Our goal is simple: construct a viable hydrocarbon trap across this geological fault. The app provides a clear 2D cross-section view, simulating the subsurface layers. On the right, we have our control panel, where we'll manipulate the geology and test our theories. We have three primary rock types to work with: shale, which acts as a low permeability barrier; sandstone, our potential reservoir rock; and limestone, another effective cap rock. Using the buttons on this panel, we can shift each layer up or down on both the footwall and the hanging wall. This slider adjusts the fault throw, allowing you to control the lithology juxtaposition in either a normal fault or reverse fault setting. One of the key mechanisms for fault sealing is shale smear. As fault blocks move, softer shale can be smeared along the fault plane, creating a seal. We can simulate this using the Shale Smear Factor, or SSF, slider. Watch as I increase the SSF. You can visually see the shale unit along the fault thickening and becoming more prominent, indicating a stronger seal potential. Beyond physical smearing, diagenetic processes play a crucial role. Post-faulting, minerals can precipitate within the fault zone, effectively cementing it shut. Here, I'm selecting Calcite Cementation as our diagenetic seal type, further enhancing the fault's sealing integrity. With our layers in place and the sealing mechanisms activated, it's time to test the trap. I'll hit the Run Fluid Flow Test button. And there it is. The simulated hydrocarbons are effectively trapped against the sealed fault plane. The message in the bottom right corner explains why. But what happens if our sealing conditions aren't met? Let's quickly demonstrate a seal failure. I'll move our shale layer away, creating a direct sandstone on sandstone juxtaposition, and reduce our SSF. Now, when we run the fluid flow test, you can see the hydrocarbons leaking right through the fault. The seal failure message explicitly tells us the reason, in this case due to reservoir-to-reservoir juxtaposition and insufficient smear. The app allows us to experiment with various scenarios. For instance, selecting clay gouge as our diagenetic process also provides an effective seal. This rapid feedback loop is invaluable for understanding the impact of different geological factors. Furthermore, by pressing the Ask Expert button, our trained AI model provides contextual, deep dive information. For example, it explains the geomechanical principles governing the seal mechanism, or elaborates on the necessary shale smear factor for a successful trap. This feature turns the app into a powerful, on-demand learning tool, offering immediate academic support for the practical results we observe. This interactive setup helps reinforce the complex interplay between stratigraphy, fault kinematics, and diagenesis. It's a powerful way to visualize, experiment with, and solidify your understanding of these critical subsurface processes. Thank you for joining this walkthrough.